to build a security alarm for our fort.
But you're gonna let me in, right?
No adults allowed.
What will happen if I try to break in?
You're just going to have to try and find out.
Well, we'll have to see about that. But if we're gonna turn this into a high-tech security alarm, there are a few things we'll have to explain first. We want to build a security alarm that will trigger when somebody gets too close to the fort. To do that, we'll use a proximity sensor. Our proximity sensor is made up of two parts, an infrared light-emitting diode and a phototransistor. Let's talk about the infrared emitting diode first. A diode is an electrical component that only allows current through in one direction. Infrared light is the same type of radiation as visible light, but it has a longer wavelength, so our eyes can't see it. The infrared emitting diode in our proximity sensor does just what it sounds like. It emits infrared light. The phototransistor detects infrared light. If there is something near the proximity sensor, then the infrared light emitting by the infrared emitting diode will bounce back and be detected by the phototransistor. When the phototransistor is triggered by infrared light, it puts out an electric current. So far so good. The infrared emitting diode emits infrared light. If there is an object nearby, the infrared light will bounce off that object and return to be detected by the phototransistor. If the phototransistor detects infrared light, it outputs an electric current. Now what do we do with that electric current? We'd like to use it to power a loud buzzer. The problem is that the current generated by a phototransistor is very weak. In order to power the alarm buzzer, we'll need to amplify that current, and we can do that using a device called a MOSFET, which is short for metal oxide semiconductor field effect transistor. We wired up those components on this breadboard. The proximity sensor, here, is connected to a MOSFET, here, which is connected to this buzzer. This is a 180 ohm resistor, and this is a 100,000 ohm resistor, and this is the 9-volt battery that powers the circuit. For the nitty-gritty details of how we chose the values for these resistors and how we wired up the circuit, go to our website at geekpackhack.com. There you can also find a video on how to use a breadboard.
Can we try it out now?
Sure, you hold this.
Time to put it on the floor. Okay, I'm going in. All adults, keep out.
They think the noise will scare me away, but I came prepared. Here I go. We hope you'll join us again next month, when we'll show you how to use a multimeter to find the problem with a mystery circuit. See our website at geekpackhack.com for info on parts and project guidance for adults. Please leave us a comment to let us know what you think, and send us your ideas for wacky hacks. If you enjoy our show, don't forget to subscribe and give us the thumbs up.